In example 9, I want to talk about this finite population correction factor. Oops. Okay, so this is the idea that when you know how large the population is, okay, the population is the group that you're trying to sample from, the size of the population is known as large N. Okay, then what we have to do is make a correction to our standard error. Okay, so let's see how this works with example 9. In a recent survey of employees at a small company, it found on average they spend 1.8 hours a day with a standard deviation, this is a population standard deviation, of 0.41 hours on the computer surfing the web. Find the probability of randomly selecting 10 people, okay, so this is the sample size, that have the average spent on surfing the web being 2 hours or more. Okay, in this part A question, notice that we don't know how large the company is. We don't know what the population size is here. So we can't use this correction factor yet. This we would do in the normal way, where we apply the central limit theorem, okay, so that we know that the average of these 10 employees will be normally distributed. Here the average, our middle is 1.8. And we're trying, oops, move that back up. We're trying to find what the probability of 2 or more hours is. We're trying to find this shaded region right here. Okay, so what we need to do is we need to transform these x bars into z's. We know that the middle will transform into 0. The standard normal's middle is always 0. Okay, so when we're using the central limit theorem, our formula is z equals x bar subtract mu over the population standard deviation divided by root n, like this. Okay, so we put in our values here. We're trying to convert this value to, the middle here is 1.8, over top of the standard deviation, which is 0.41, and our sample size here is 10. Okay, so if we do this, we'll find here that this x value transforms into the value 1.54. Okay, so now all we need to do is just go to our z table to find out first the cumulative probability, and then here to find the probability we're interested in doing the complement of our cumulative. Okay, so in our z table, here this is the cumulative z table, we're looking at this value 1.5 and where it matches up with 0.04, and we get this number to be 0.9382, and then obviously the complement of that is when we have 1 and we subtract the probability we just found, which will end up being 0.0618. Okay, so this is the area of that's shaded here. Okay, so that's without using the correction factor. We couldn't use the correction factor because we didn't know how large the population size was. Okay, so let's look at B. It says if this survey was based on a company that had 120 employees, okay, so now we do know the population size, then we want to find the probability of randomly selecting 10 employees and them spending 2 hours or more surfing the net. So the exact same question, the only difference is now we know what the population size is here. Okay, again, we're going to be using the central limit theorem. Okay, we've got the middle here, which is again 1.8, and we're trying to find the probability of being greater than 2. These are our x bar values. We need to transform them into z values. Okay, so we want to find what value this 2 transforms into. Okay, so we need to use our formula that we're familiar with here. But here, because we know what the population size is, then we need to add on this correction factor here. This is large N subtract N over large N subtract 1, and this is square root. Okay, so This is because we know the population size. Okay, so this is the population size correction factor. We should use it when you know what n is. Okay, so that's fine. Now that we have the formula, let's just input our values. Okay, so here we're going to have our x bar, which is 2, subtract the middle, which is 1.8, over top of our standard deviation, which is 0.0 or 0.41 over top of root 10. And now we put in our correction factor here. Large N was 120 people. Subtract our sample size, which is 10, and our population size, subtract 1, and this is square root in the bottom here. Okay, when we do this, we get our Z value to be approximately 1.60. Okay, so we now know this value to be 1.60. Again here, we find this shaded region, which is the greater than side, by first finding the less than or equal to sign and then finding its complement. Okay, so we can do that by looking up in our chart. Remember, our chart is always a cumulative chart. 1.6 and where it matches up with 0.00 so that we can look up this value here. And we find this value to be 0.9452. We find the complement, which is the tail region here, by having 1 and subtracting that probability. And we get here that the probability of this happening is actually 0.0548. Okay, so there's a little bit of a difference between A and B, and that's just because we now know what the size of the company really is. This is, remember, part A is assuming that the sample is infinitely large, extremely large, and you can see the differences of when you do that.